Good afternoon, Mr. Tulia. My name is Yusuf Fidel, and I'm going to introduce you to three scientists from various backgrounds who have impacted the STEM field. The first scientist that I would like to spotlight is Lewis Latimer. Lewis Latimer was an African-American inventor and draftsman from Chelsea, Massachusetts, New York. His parents had fled slavery in Virginia just 6 years before his birth. However, he was recaptured into slavery in Boston and was eventually forced to purchase his own freedom with the help of a local minister, which is when he began to raise a family in Chelsea. So at Lewis Latimer's time in the 1800s, black men had to purchase their own freedom from slavery. Latimer went on to work diligently to help support his mother and family through his scientific work. He designed various different inventions that drastically contributed to the advancement of technology of his era. He was very self-taught and taught himself mechanical drawings and independently developed the designs for an improved railroad car bathroom and even an early evaporative air conditioner. Furthermore, Latimer worked with the famous inventor Hiram Maxim at the U.S. Electric Lighting Company. This is where he patented a carbon filament for the incandescent light bulb, which was more durable and longer lasting than previous incendiary filaments. His ingenuity helped make electric lighting practical, affordable, and even safer than other popular lighting technologies at the time, such as gas lamps and arc lights, which were highly flammable and often burned people's homes. You can even say that he made lighting accessible for the average household. Latimer also drafted the drawings that Alexander Graham Bell would eventually use to patent the world's first telephone in 1876. Another scientist who I believe deserves praise for their scientific achievements is named Qiansheng Wu. Qiansheng Wu was a Chinese-American physicist who played an important role in the Manhattan Project. If you didn't know, this project was a research and development undertaking during World War II that went on to produce the world's first nuclear weapons. During this project, she worked at Columbia University to help in developing a process that separated uranium into two of its isotopes through gaseous diffusion. Her discovery created a way to enrich uranium ore to produce larger quantities of uranium, which was very useful as fuel for the bomb that was in the Manhattan Project. However, she eventually left the Manhattan Project. And after she did so, Wu spent the rest of her career in the Department of Physics at Columbia as the undisputed leading experimentalist in beta decay. And beta decay is a type of radioactive decay in which an electron is emitted. During this time, Wu conducted experiments using the element cobalt-30. She used a radioactive isotope form of cobalt metal, or a radioisotope, and she conducted her experiments at absolute zero temperatures. Her research upended the law of conservation of parity, which says that parity is conserved in a universe, which could also mean that the laws of physics are the same in a right-handed system of coordinates as in a left-handed system. So you could kind of say that they are mirrored. She disproved this law by displaying that it did not hold true during beta decay, and that identical nuclear particles do not always act alike. Wu continued making significant contributions throughout her life and won several awards and honors. In 1958, her research helped answer important biological questions, including questions that were related to blood and sickle cell anemia. Additionally, her book on beta decay, published in 1965, is still a standard reference for nuclear physicists till this very day. Unfortunately, however, she was not awarded a Nobel Prize alongside her male coworkers, who were Yang and Li. This is likely due to the strong bias against women and injustices that many women of color faced at the time. The final scientist that I'd like to spotlight is Mary Jackson. Mary Jackson was a mathematician and the first African woman aeronautical engineer and NASA's first black female engineer. She excelled academically in a period of racial segregation, and her work centered on the airflow around aircrafts. After just 2 years in the computing pool, Mary managed to receive an offer to work for a famous engineer at the time named Casimirs in a supersonic pressure tunnel. This was because he saw great potential in her and was impressed by her intelligence. Casimirs offered Mary hands-on experience conducting experiments in the facility, and eventually even suggested that she enter a training program which would allow her to earn a promotion from mathematician to engineer. This was very impressive for anyone at the time, and specifically impressive for a black woman. Jackson would go on to work directly in the National Advisory Committee for Aeronautics, and she even provided data that would later become essential to the early success of the US space program. Mary Jackson's contributions to science, and even the world as a whole, as a successful independent black woman in STEM, influenced NASA to name one of its headquarters after her. This headquarters is called the Mary W. Jackson NASA Headquarters and can now be located in Washington, D.C. Here are my references that I used for this project. Thank you so much for listening, Mr. Tulia, and if you have any questions that you'd like to direct towards me, you can ask them or you can email them to me. Thank you so much for listening. Have a wonderful day.